It's Justin Dickmeyer from EngineeringAndTrainingExam.com, and in this video we will reinforce your understanding of the cross product of two vectors. The difference between dot products, which we discussed in a previous video, and cross products is the result of a dot product is a number or scalar, and the result of a cross product is actually a new vector. So let's start. Say we are given two vectors, say A with the components A1, A2, and A3, and the vector B, components B1, B2, and B3. Now the cross product is given by the formula A cross B. The new vector, or the cross product, is A2, B3 minus A3, B2. A3 B1 minus A1 B3, and A1 B2 minus A2 B1. Sorry, I got kind of sloppy there, but this is typically not an easy formula to remember. I mean, we're not going to get into our exam and remember to do this formula. So let me show you an easy way to remember the cross product of two vectors. Now the cross product can be written as a 3x3 matrix. I, J, K, A1, A2, A3, B1, B2, and B3. Now the first row is the standard basis vectors and must appear in the order given here. So it's I, J, and K. The second row is the components of vector A, and the third row are the components of vector B. Now, so how do we get the equation of the cross product from here? The first method uses the method of cofactors, the same method we used when we were looking for the determinant of a 3x3 matrix. So let's illustrate. The cross product of A and B is equal to A2, A3, B2, B3, I minus A1, A3, B1, B3, J plus A1, A2, B1, B2, K. So if you remember, we took the first basis vector component I, we eliminate the row and the column that it's in, and we make a 2x2 matrix, which you see here, and we just repeat that throughout to get our components using this is called the method of cofactors. Now remember, the terms alternate in sign, and each individual term is simply just a 2x2 matrix multiplied by a scalar. So the cross product can also be geometrically interpreted, and assuming we have two vectors, say A and B, and that we have a certain angle theta between those two vectors, assuming that theta is between 0 and pi, then the geometric interpretation of the dot product of A cross B is equal to the magnitude of A, the magnitude of vector B, times the sine of theta. So this is the general formula. If we're looking to find the angle, say we have two defined vectors, and we're asked to find the angle between those two vectors, we would use this formula. Using our general formula, using the method of cofactors to define the first term, then getting the individual magnitudes of the vectors, simply plugging them in just like we did in the dot product to determine the angle between the two vectors, and simply just solve from there. So let's just finish off by looking at a quick example of how we would use the cross product. Say that we're given 3 points in a single plane. We got point P, which is 1, 0, 0. We have point Q, which is 1, 1, and 1. And we have point R, which is 2, -1, 3. So let's say we're asked to find the cross product of the vectors that are made by these 3 points, that are defined by these 3 points. So the cross product of two vectors is a new vector that is orthogonal to the original vectors. So we need to define the two vectors that are in this plane. This is where the points come into play. Say there are many ways to get two vectors between these points, but we will use P as the basis, as the origin, and we will determine vector PQ, and we'll determine vector PR. And we just do that by simply taking each point, A1 minus or P1 minus PQ, or Q1, etc. So we find that vector PQ is 1 minus 1, 1 minus 0, 1 minus 0. So our vector is the components 1, 0, 1, and 1. Same deal finding the vector PR, and we find that our vector is 1, negative 1, 3. So now that we have our two vectors defined, we can use the method of cofactors to determine the cross product of these two vectors. So we got PQ cross product PR. We write down our basis vector ijk, plug in our information, our components of our two vectors, 0, 1, 1, and 1, negative 1, 3. Now just simply doing the method of cofactors, we find that the cross product is 1. So starting with I, once again eliminating the row and the column, we got 1, 1, negative 1, 3, I minus 0, 1, 1, 3, J plus 0, 1, 1, negative 1, K. So determining these are 2 by 2 determinants. Remember, just defining these terms, we find that our new vector is 4I plus J minus K. So our cross product of PQ cross PR is 4I plus J minus K. So that's it, guys. That's all there is to the cross product. Once again, the difference between the dot product and the cross product is that the dot product is a single number, it's a scalar, and the cross product is going to give us a new vector. So if you guys have any questions, hop on over to engineerintrainingexam.com, shoot me some feedback, your suggestions, or if you guys have general questions, go ahead and get in contact with me. I look forward to hearing from you and talking with you soon. All right, take care.